After the warm-up, the next thing that we're going to do is work through finding if these expressions are equivalent to 4x plus 2b or not equivalent. So we're going to take them one at a time. The first one says 2b plus 4x minus 2b. Pause your tape now. It should take you about 10 seconds to figure this out. Okay, 2b minus 2b. If you have 2b and you take away 2b, you're not going to have any b's left over. So that is not equivalent. We'll bring up the next one right here. It says b plus 3x plus b plus x. Should take you about 20 seconds to figure this one out. Okay, when you combine your b's, 1b plus 1b is 2b, 3x plus 1x is 4x, so that is equivalent. The next one, 2x plus 2b plus 3x. Well, the 2b looks good, but 2x plus 3x is 5x, so that's not going to work for us. This one, I'm going to rewrite this one. You can copy it down and actually work this one out in your notebook. It's 8x plus 6b, and then I got to scroll a little bit to get to the rest of it, minus 4b minus 4x. Minus 4b minus 4x. So when you take a look at this and you actually code this, you have 8x and then you're taking away 4x. You have 6b and you're taking away 4b. So look, again, when I coded this, there's nothing floating around. 8x minus 4x is 4x. 6b minus 4b is 2b. That is what we're looking for. Here it is. I'll scroll this one out. It says 3x plus b plus 3b minus 2x. 3x plus b plus 3x. Plus 3b minus 2x. Plus 3b minus 2x. So as you work through this one and code it, you know that we have 3x minus 2x, and we have 1b plus 3b. So 3x minus 2x, that's only going to be 1x, so we should know right away that that is not equivalent. The last one, x plus 9b minus 7b plus 3x. So as we start to code this one, we have 1x here plus 3x. So that's 4x. So far we look good. 9b minus 7b is 2b. So this is going to be equivalent. All right, today's lesson, we're going to be simplifying expressions from geometric problems. So basically from shapes. And this problem says, what is the perimeter of the figure shown below? And you see a rectangle. Well, the first thing I'm thinking is that when I want perimeter, I'm talking about the distance around the outside. So essentially, what is all of this going to add up to? Perimeter is things like putting a fence around or a border on a bulletin board, or if you're thinking of this as a football field, these would be the out-of-bounds lines all around the outside. So I know that if these were regular numbers like a 5, a 5, a 10, and a 10, I'd add them all up. Well, nothing changes if you have terms. You still can put the like terms together to add them up. So in this problem, you have two constants, positive 10 and positive 10. And then you have a bunch of like terms, 4x, x, 4x, and x. So to write an expression to show the perimeter of this, really all we're going to do is add up our like terms. So we have 10 plus 10, which is 20, and we have 4x plus 1x is 5x, 5x plus 4x is 9x, 9x plus 1x is 10x. So an expression to represent the perimeter of this would be 20 plus 10x. That represents the total distance around the outside. I'm going to show one other example here, and then you're going to take your time and try a couple. I'm going to show this triangle here. So for each of these problems, we are trying to determine the perimeter. The best part about this is I can code it right from the picture. I have my 2n, and I have my 3n, and I have 6 and 8. So perimeter means you add up all of the outsides. So I can add 2n plus 3n, and that gives me 5n. I can also add 6 and 8 because they're both constants, and that gives me 14. So an expression to represent the perimeter of this triangle is 5n plus 14. Your job is to now try the other 3 problems. One hint I'll give you is on the rectangle down here. Perimeter represents all of the sides, so when you draw the picture, make sure you label those missing sides. Pause the tape and figure it out now.